Hey guys, welcome back. So this is our last section in the equilibrium unit here, and it's on predicting precipitation of solids. Pretty short one here, shouldn't be too long. The idea is that if you're given the concentrations of ions in a solution, so I tell you how much of each ion there is, you can actually figure out if the entire substance has dissolved or if you have a precipitate, if you have some solid left over. And it's 2 steps, it's not too bad. You take the values you were given, so your concentration values, put those into the equilibrium expression. So whatever your, KSP equals concentration of product 1 times product 2. And whatever exponents you might have. So just plug that in. You solve for, let's call it KSP prime. You figure out what that value is, and then you check it against what KSP is supposed to be for that substance. If there is too much solid to dissolve, if your answer is larger, so if my KSP prime here is bigger than what KSP is supposed to be, then there's too much solid to dissolve, which means you have a precipitate. So you're just checking your KSP against what KSP is supposed to be, is basically the idea here. So let's hop in. Will a precipitate of lead 2 bromide form, and here's your KSP, it's 1.4 times 10 to the negative 8. 1.4 times 10 to the negative 8. So that's what KSP is supposed to be. So will a precipitate of lead 2 bromide form if I'm giving you 2 chemicals? I give you 25 milliliters of 0.1 molar calcium bromide, and I give you 25 milliliters of 0.1 molar lead 2 nitrate. All right. So step 1 here, you've got 2 beakers with 25 milliliters each. You're going to mix them together. Since you're mixing 2 solutions, I've mixed 25 milliliters plus 25 milliliters. I now have 50 milliliters, which means my concentrations are all going to change. So we need to first calculate what are our actual concentrations. So let's look at so the only ions I care about are the lead 2 plus and the bromide. Those are the ones that I'm checking for. So those are the only ones I care about. So I need to check my lead here and my bromine here. I can ignore the calcium and I can ignore the nitrate because they're not a common ion. They're going to have nothing to do with the solubility of my lead 2 bromide. So let's do lead first. So I'm looking over here. So I have 0.1 moles per liter. That was the original concentration. I'm going to times this by 25 milliliters. Well, that's liters. I changed my 25 milliliters into liters so I can cancel out my liters. So it turns out I had 0.0025 moles in total. And my total volume is now what? Well, I had 25 milliliters here, 25 milliliters there, so it's now 50 ml. Or 0.05 liters. So if I want my concentration of lead, I take how many moles I had, divide it by how many liters it's in. That'll give my answer in moles per liter. Pull my calculator here. 0.0025 divided by 0.05. 0.0025 divided by 0.05. Okay, I'm not crazy. The answer is 0.05 still. So that's the concentration of my lead 2 plus. Now I've got to figure out what my bromide is going to be. So, where's my bromine? Here it is. So I had 0.1 molar. Okay, I skipped a step on the lead 2 bromide, but didn't actually affect my answer. But I'm going to show you one. I'm going to show you here what I accidentally skipped. So I had 0.1 moles per liter, and that is of calcium bromide, right? And it is 0.025 liters. So again, I have 0.0025 moles of calcium bromide. I should label this as well. This was lead nitrate. Now, the step I skipped was going from here to here. How do I change lead nitrate into just Pb2+? You have to look at your mole ratio. So when this breaks down, it gives me lead and nitrate. 2 nitrates. So the ratio here is 1 to 1. So if I had 0.025 moles, I still have 0.025 moles. So this is okay. But take a look at this one. Calcium bromide gives me 1 calcium, but it gives me 2 bromides. So how many moles of bromine ion, bromide, do I actually have in this solution? I don't have 0.025. I have 0.025 times 2 because of the mole ratio. I have twice as much bromine as I do calcium bromide. So I'm actually at 0.005 moles. And how many liters of solution? Well, it doesn't change. It's still 50 milliliters. So my actual concentration, 0.005 divided by 0.05, is 0.1 molar for bromine. So hopefully we're following there. So you have to not just look at what the concentration of that chemical is, you also have to look at its mole ratio. If I'm only looking at the bromine here, I have to double it. So just a little bit of stoichiometry to keep track of. All right, so I've got my concentrations now. So I mix these 2 beakers. In this beaker, I have 0.05 molar lead 2+, and I have 0.1 molar bromide ion. All right, so far so good. So our balanced equation. I've got lead 2 bromide, which should be a solid, is going to give me lead 2+ plus 2 bromides. All right, sweet. So what is our equilibrium expression then? KSP. So this isn't the true KSP, right? So I'm going to call it KSP prime. Just put a little ticky mark on it. That's a notation you see in calculus quite a bit. If you end up taking calculus, you get a little prime mark on it. So we're going to call this KSP prime equals our products. So the concentration of our lead 2+ times the concentration of our bromine. And of course, mole ratio is 2, so got to square it. Divide by reactants. Reactants are solid, I can ignore them. Makes life a little bit easier. All right, and so step 4, check if the answer above is greater or less than. So I actually have to work this out now. So my KSP was, what was it? 1.4 times 10 to the negative 8. Equals concentration of lead. Where was it? Let's change my color here so we see a little better. There's my concentration of lead, 0.05. And my concentration of bromine at equilibrium, I found here, 0.1. And of course I have to square that. Oh, sorry, big mistake. I don't want to put my KSP in there yet. That's what I want to compare against. I need to find my KSP. So I don't want to plug KSP in here because I'm finding my own. I'm finding KSP prime. So I don't want to use KSP. I want to calculate KSP for this. So I take 0.05, I times it by 0.1 squared. And it gives me an answer. KSP prime should be for this 0.01. Step 4, I need to check. Is KSP prime greater than the regular KSP? That's the question I'm asking. So is 0.01 greater than 1.4 times 10 to the negative 8? And I think we could all see pretty quickly that yes, it definitely is greater. So my KSP is much greater than the true than the true KSP, which is given to you in the question. And what does this mean? Well, if my KSP is bigger, we are going to form a solid. We're going to have a precipitate here. We're going to have something drop out. If my KSP was smaller than the true KSP, it means all of it would dissolve. It means there's not enough in there to actually keep something solid, and it would all dissolve into the solution. But because my KSP is much greater than the actual KSP, we form a solid. So quick recap here. Get a couple chemicals. Step 1, you're going to have to re-find your concentrations. So find how many moles of each section you're interested. So I'm interested here in the lead and the bromine. So I would have to find how many moles of lead do I have? How many moles of bromine do I have? Don't forget to include your mole ratio when you're doing that. I got lucky. I forgot it in step 1, but it was a 1-to-1 ratio, so I was okay. So be very careful. Make sure you don't forget your mole ratios there. Use your total volume in the last step. So you find how many moles you have just in this beaker with the 25 mLs. And then to find the concentration, you take that many moles and you use your total concentration from both beakers, or total volume, from both beakers combined. Once you've got your concentrations of your 2 ions that you're interested in, write out your balanced equation for that dissolve. So I'm interested in the lead bromide, so this is what it would look like. I use that to make my equilibrium expression. I don't put KSP in because I'm trying to find my own version of KSP for these concentrations, which I've been calling KSP prime. So you calculate KSP prime and then compare it. Is your KSP prime, bigger than the true KSP, the one that's given to you in the question, or you'd probably have to look it up out of a book or something somewhere. So how do they compare? If your KSP is bigger, if it's greater, then you have a solid. If your KSP is less than that, then you would not have a solid form. It would all dissolve. And that's it. That's all there is to it. So it's a little bit of stoichiometry up front, but if you get through that, actually figuring out if it dissolves or not is pretty straightforward. So thanks for watching, guys, and that wraps up our equilibrium unit. So we'll be going into a little bit of review after this, and then we'll move into our next unit. Thanks, guys, and I'll talk to you later.